CE? Does that look pretty good? Bottom of a valley? I like it. Local min? We got a local min. There you are. Those are the places. I don't think there are any other places that's a local min. It's the absolutes that are the really good ones. So I'm going to circle that absolute max. So we had that absolute max was at F. And then our absolute min, if you want to locate that one in there, is going to happen over at A. This is the absolute minimum, the lowest of the low in our particular interval, in our domain. So that's absolute min. So there's a lot going on in there. Those are just the names of those things. So just getting an idea of what to call them. Local minimax or peaks and valleys. Absolute maximum means like the tallest points possible in that domain. So just for rounding this all off, what if we had this graph? I'm going to make it as big as I can without going off there. I went like that, and this is A, that's B. And this graph tapers off. Maybe I should clear that up a little bit. Okay, there we go. A little better drawing of that one. We would call this a local max. So I'm just going to go kind of loco. Just write them in there. Local min. So you find those local max and local min. Also, if I do it in this particular graph, oh, this should have an arrow at the end here. The local max, turns out it's also the absolute max because it's also the highest possible point that it gets to. Okay, so in this one, here, right here, this is also the absolute max. Okay, because it's the highest. Do you see any other place on there that's higher? It's like the local maximum is like saying, I'm in a small town. Everybody's like, let's go nearby local town. What's the hill that's highest in our part of the town? Somebody goes, oh yeah, it's over there. It's like, you know, particular hill, Chandler's Sledding Hill outside of town. So you go there, you climb up to the top of it. Hey, these guys expand out. Maybe they've been kind of a hermited kind of town, like enclosed population. They go out and explore and they find out not only is their little hill the local maximum, like the highest little peak in the town, they find out that's the highest elevation in all of their island country, coincidentally. That would mean it's the absolute max in that town as well. But locally, it's the biggest peak, can sometimes be the absolute max in that case. But on an interval, there you go. Those are examples. Chandler's little molehill. Okay, identify local extrema in this little dude. Let's get this graphed. All right, this is where we're going to grab our calculators. If you would, let's get going with the calculator. How do you find a local min and a local max with your calculator? If you didn't do it before, you can definitely do it now. You got to know these keystrokes. Let's do it. So I'm going to turn off other graphs. Yeah. Let's do x to the fourth minus 7x. Sorry, I covered it up, but this one's already in your book. X to the fourth minus 7x squared and plus 6x plus 6x. Yes. A little zoom 6. Ooh. Okay. Behavior-wise, this is an x to the fourth positive, so I know both arms should end facing up because that's what happens when you have a nice even function. It should be facing both arms up. So that looks good. Looks like I have almost the whole graph except for the bottom. It's getting chopped off. So I'm going to lower my window to try and catch what I think is going to be a local minimum down there. So I'm going to go my y minimum to negative 30. Just really open this thing up. See what I got. Oh yeah, we're in there. So it's down, up, down, up. You're good to go. To find the local max and min, let's do the local minimum on the left, the bottom of that little trough there on the left. Remember, you do second calc or second trace, and it brings up the option minimum. So your second trace, and you go to number 3, third option down, at minimum. The left bound thing means whatever this thing the minimum you're trying to find, go left of it. As far left as you need to, as long as you're on the screen. Okay, so I'm left, hit enter. Right bound, go right of that. So you go over here to the right somewhere. As long as you're right of it, doesn't matter where, enter. And then guess is to specify if there's specification needed. I'll show you where it comes in handy a little bit later. And then you hit enter, and I got it. Negative 2.05-ish. So if we rounded to hundredths, negative 2.06 and negative 24.06. Sound good? Let's do it. So I'm going to go back to my sheet, bring it back up, slide it open. Minimum, the local min is, it looks like, and now these are coordinate points. Okay, so this is not a range or a domain or anything like that. I'm just saying at this point, negative 2.06, I get to a minimum of negative 24.06 in height. So it's a coordinate point, and that may be something to specify over here. These are chords that we're dealing with now. That looks weird. Quirks. Okay, so we got local min. If there's another local min, we should probably find that. So I'll go back to my graph. And the same process. You go second trace, choose minimum, third option down. Let me show you what guess can do for you. It says left bound. I'm going to go way left, like way left. Like I'm definitely left. I'm interested in this bound, the lower bound here at the right-hand trough here. But I'm going to hit enter way to the left. And then I'm going to go right bound way. See that little triangle up there? It tells you where you last left your marker. I'm going to go way to the right. I mean, out there. Look at that. Way. Without going off the charts is all I'm interested in. Stay. Okay. Hit enter. This is where guess would be important, because if I didn't guess and put it somewhere near that right-hand valley or that local min, it could potentially choose the other one. So this is where guess helps. It's a means of saying to the calculator, I mean that one. That's what I want you to guess at. And it'll pick it for you. So 1.6-ish and negative 1.77 is where we'll go. Okay, so there it is. Our local min, negative 1. Is that positive? Yeah, it's positive 1.6. And negative 1.77. There. Now the max, local max, I'll just put it right next to it, L max. There's only one of those. And if I do that right now, second calc maximum, which is number 4. You do need to choose the appropriate one. Left bound, there's a little peak right there, not too far from the origin. So I'm left of my peak, go right of my peak, guess my peak, 0.45, 1.32, roughly. So that's one of the really cool features of your calculators, finding a peak or a valley. Really handy. And I think that abbreviation, what was it? 0.46, comma, 1.32. Okay, so local max, local min, they're coordinate points, not range of values. Another one, you guys get this one. Grab a calculator, see if you can find these. I'll just throw a key up there, see if you can get these right. 2x cubed minus x squared minus x minus 1. It's all yours. Try that. Try and get that one. Yeah. So you're typing it in there. I'll enter it in mine. Actually, I'm just going to put up the answers and just roll with it. But Try and get the local max and local min for these, whatever you happen to have. Lmin, Lmax. Put that graph on the right. And let me know if you have calculator things I can help with too. That'd be good. Making it. Okay. While you guys are doing that, let's see if I have any new members. Nope. Nothing new there. Okay. Lmin, Lmax. All right, the big reveal. 0.61, negative 1.53. Space. Negative 0.27, negative 0.84. Bam. Is that great? How'd you do? Hang it in there? Is that okay? Once you get that tool down, you never go back. It's a great one. Nice. Get those rolling. We're going to keep rolling. I think I've got, oh yeah, we can do this. We are finished at 22 after. It's currently 04. Oh, we're going to do this. Next, symmetry. Symmetry, I believe, is the British pronunciation. Have you heard that before? Symmetry? Okay. Y-axis symmetry would be this axis, you know, it reflects over the y-axis. That might be a good word to put in there. Reflects. We've done reflections before. Reflects over y. That's a good one. Numerically, this table is just a nice way to say, hey, did you notice that for the negative values of x and its corresponding positive values of x, you get the same outputs? That's cool. Symbolically, that means if you put negative x in to the function, you still get the same f of x function out. Here's the things I want you to put in there. Very lightly over here it says even. Y-axis symmetry is also called even symmetry. That's pretty common to call it even symmetry. Y-axis symmetry is even symmetry. Okay, got that piece. I'm going to keep rolling, and I'll show you how to determine what's what in a next situation. So keep that one tucked away. Trying to flip my page. X-axis symmetry. Can you imagine this is reflecting over the x-axis? Reflect over x-axis. Okay, that's good. Numerically, what you're noticing if you take a peek at it, I've got these x inputs. Notice it's not a function. 9 gets 2 different results, but it has that nice mirrored look across the x-axis. It's not about being a function. It's just saying what's its symmetry. My son, coming out of kindergarten last year, he comes home and starts telling me about symmetry. He's like, oh, look at that star. It has symmetry. And I said, then you can ask him, draw on the line of symmetry, and he can divide it in half. They just know it has to look the same on both sides. And they do it in kindergarten. Isn't that crazy? So, lo and behold, we are in good shape when it comes to the future because the next generation is awesome. Wait a second. You guys are awesome, which means you're great for taking care of me when I decide to not function for myself. Okay. Got that? Reflect over the x-axis. Good. Next, the symmetry with respect to the y-axis is a complete typo. It's supposed to be origin. We already did symmetry with the y-axis. Sorry. Symmetry with respect to the origin. This one is also known as odd symmetry. And it means if you take a point on the right and then the origin, and you tether it with some kind of chain or something, and you flip directly over the origin, you'll land in a mirror position